Welcome back to lesson 14 of our Balancing Forces unit. Remember, we've been trying to figure out this question in chapter 4. Why does the train float even though gravity is acting on it? Before we get into our next activity, let's take a review of the concepts that we already know. I'm going to look at our home science wall that is always on the end of our writing assignments. So I'm going to go through these first couple pages kind of quick because we've gone through these a couple times before. So our chapter 1 question was, why does the train rise? And our key concepts were that a force is acting between two objects, and when an object starts moving or stops moving, that is evidence that a force has acted. Our chapter 2 question was, why does the train rise without anything touching it? And we learned all about magnets during that time. We learned that magnets are non-touching forces and that they can attract or repel other magnets and some other metal objects. Our chapter 3 question was, why does the train fall? And the big concept we learned from that was that an object falls because Earth pulls the object toward it with the force of gravity. So you guys wrote some really good scientific explanations to explain that the train falls because of gravity pulling it down. Here we are now in chapter 4. Our question is, why does the train float even though gravity is acting on it? And our key concepts that we've learned so far are that two forces can be exerted on the object at the same time. And when two forces are exerted on an object in opposite directions, the forces can be balanced. So on Monday, you learned in your class that forces that are balancing forces cause an object to stay still. Here's some of our vocabulary that we've learned. Force, touching force, non-touching force, magnet, magnetic force, attract, repel, gravity, diagram, exert, and then balanced forces. So pay special attention to these last couple of words for today's lesson because you're going to want to use them in your scientific explanation. A couple weeks ago, we noticed a student made a model with these materials to represent how the train floats even though gravity is acting on it. So we have a pencil, a piece of cardboard, and two magnets. Here's a picture of the model that that student made to give you a little reminder. Notice that he has the magnets on the pencil with the cardboard in between, and that top magnet is floating above the cardboard. So we're going to spend some time thinking about this model with our think, pair, share routine. Remember, I'm going to ask you a question, and then you're going to pause the video and either say your answer out loud, or even better would be to find a partner at home that you can give your answer to. So here is our question. Why does the train float even though gravity is acting on it? And I want you to use that model in your answer. How is that model helping you give an answer to that question? Okay, pause the video now and answer that question. All right, third graders, welcome back. Hopefully in your answer, you said something about the train floating even though gravity is acting on it because of the balanced force from the magnets. So in this model, you can see that the two magnets are repelling each other, which is causing the top magnet to float because it's being pushed away from the bottom magnet. The reason that it's floating instead of just going up, up, up is because of gravity. Gravity is pulling the magnet back down at the same time that the repelling force is pushing it up. So those two forces are balanced forces. And since they're the same strength, the magnet just stays in one place. Now, the next question is a little bit different. How is this model similar to and different from the floating train? We've been using this word model a lot, and so before you answer that question, I want to talk about that word a little bit. Every scientific model is similar to and different from the thing that it shows in some ways. So here are some examples in the pictures of two different models. In this top picture, we have a model of an airplane, and in the bottom picture, we have a model of a stream. As it says here on the slide, having the model be simpler, smaller, or easier to change than the real thing makes it easier for a scientist to show her ideas using the model. So often scientists build a model to kind of investigate their ideas and test them out, so that obviously they can't use a real airplane if they're investigating airplanes. And with a model, they can actually move it around and change it and do what they need to do to investigate it. So models are really helpful tools for thinking about scientific ideas when we can't use the real thing. So now that you know a little bit more about that word, here's your second question. How is this model that the boy is holding similar to and different from the floating train? Pause the video now and answer that question with your partner. All right, scientists, hopefully your answer involved something about the model being similar because it shows an object floating above another object. And it's different because it's not actually a train, right? It's just magnets. So remember, we have been investigating the floating train in order to explain how it works to the people of Faraday. We have this town and they're getting this new floating train and they're kind of nervous because this is completely new and different from anything they've seen before. And it's our job to help make them feel better about how the floating train works. As it says here, if we can explain to them how it works, they will be less worried about writing it. So once again today, you will write a scientific explanation to help the people of Faraday understand why the train floats. Thinking about when the train is stable and when its motion changes can help you. Those are some important words to think about your answer. Just a reminder, a scientific explanation has 5 parts. First of all, it answers a question about how or why something happens. Second, it is based on the ideas you have learned from investigations and text. Third, it uses scientific language. Fourth, it is written for a specific audience. And fifth, it describes things that are not easy to observe. Before we get into what your scientific explanation is going to look like today, I want to show you some examples of some really good scientific explanations that are coming from some students in my class. A really strong scientific explanation from a student in my class. This was from the one you guys did last time, which was answering the question, why does the train fall? The text they wrote says, I think the train falls because of electronic magnets turning off. Magnets could be on the bottom of the train and on the track. The magnets could be repelling each other and then someone could turn the magnets off. The train would stop and fall. My evidence is the books we read. I learned about gravity in different books and I read about electromagnets in Handbook of Forces. I think the train falls because of electronic magnets turning off. So what I really love about this explanation is that it includes the 2 most important parts of a scientific explanation. The first one is that first sentence where the student answered the question. I think the train falls because of electronic magnets turning off. They clearly answered the question. And the second reason I love it is the evidence that they gave. My evidence is, and then they explained the books that we read, 2 different books where they found this information. Okay, so a strong scientific explanation needs to answer the question clearly and give some evidence using that sentence. My evidence is. All right, let me show you another example. And this is a different answer. So I'm not even talking about whether these answers are right or wrong. I'm just showing examples of good scientific writing. This one says, the train falls because there are big magnets under the train to make it drop. So that means that there are big magnets that flip the train and it repels. And when it is on the right side, that is a sign of non-touching force. My evidence is that in the video, the boy, when he flips the magnet and it repels, that's the same thing with the train, but bigger magnets. So this again answers the question right there in the first sentence. The train falls because there are big magnets under the train to make it drop. And then later on in the paragraph, My evidence is that in the video, when the boy flips the magnet and it repels. So once again, the student used that sentence, my evidence is. Okay? When you write your scientific explanation today, make sure that you are doing those two things, answering the question right away, and then later on saying, my evidence is, and giving some evidence from what we've learned. Your job today is to do another scientific explanation answering the chapter 4 question. Why does the train float even though gravity is acting on it? Think about all of the evidence we've collected in this chapter. We read a little bit from the Handbook of Forces about balancing forces. We watched a couple different models. Today we looked at that boy's model of the magnets, and we also the other day in class looked at the model of the floating paperclip. You also did an investigation at your house of objects moving when two forces are acting on it. So you have a lot of evidence to choose from to help you answer that question. When you answer it, remember your first sentence needs to be a clear answer of the question. So you would start with, the train floats even though gravity is acting on it because, and then give your answer. And then explain a little bit more about that answer. Later, when you're ready, you should start a sentence with, my evidence is, and then tell us what evidence you're using to give yourself that idea. Okay? All right. I'm excited to read the explanations that you write. Go ahead and go now to the Kami assignment and get started on your writing. Good luck, scientists.